Examine our current cultural landscape, and it is easy to find a growing anxiety that we are becoming obsolete. We often imagine a future defined by a harsh contest between humanity and the machine. This visualization shows the scale of that concern. Studies suggest that between 20 and 40% of current jobs are on the verge of fracturing or transforming. Yet quantitative researchers looking at the economic data see a different trajectory. By 2035, robotics and AI are projected to add $13 to $15 trillion to the global GDP, an expansion roughly the size of the current Chinese economy. The economic data suggests we are misidentifying these systems as replacements. In reality, they function as multipliers of human output. The challenge lies in our ability to adapt, ensuring we pivot our skills toward the creative and strategic roles that machines cannot replicate. To understand how these systems work, we have to look at a specific division of labor, the separation of mechanical execution from strategic intent. Machines are optimized for execution. They excel at repetitive, dangerous, and data-heavy tasks, like those performed by this industrial robotic arm on a factory line, or in deep-sea mining and global logistics. Humans, however, retain control over intent. We thrive in areas where machines struggle, applying empathy, navigating ethics, and executing complex judgments. This historical pattern has played out before. When farmers adopted the tractor, it didn't end farming. It augmented food production and made individual farmers more productive than ever. We saw this repeated during the digital revolution. Early mainframes disrupted existing workflows, but they ultimately created new career paths and raised living standards globally. Relieving ourselves of the mechanical burden is the first step toward elevating human potential. The result of this shift in the workplace is augmentation, where we treat robots as super tools. In science, a researcher paired with a robotic laboratory can iterate experiments 100 times faster than they could alone. Drug discovery that once took decades now happens in months. In healthcare, a surgeon utilizing robotic arms operates with superhuman precision, which significantly reduces errors during critical procedures. These tools remove the physical limits of human performance while remaining reliant on human judgment to set the goal. This chart illustrates that as robotic efficiency causes production costs to fall, the availability of goods and services rises. This growing abundance translates directly to safety. Self-driving technology has the potential to eliminate up to 90% of road fatalities by removing human error from the equation. In social care, smart homes and companion bots help reduce elder loneliness and lower the financial strain on healthcare systems by supporting independent living for longer. This efficiency gives rise to a robot economy, a landscape where human-centric roles like AI ethics, virtual design, and personalized care become the new standard. Navigating this transition requires strong safety nets. Programs like Universal Basic Income or tech-funded retraining initiatives can smooth the path for those moving into these new sectors. Just as the tractor and the computer expanded our economic reach, automation provides the surplus necessary to reinvest in fields that require human empathy and personalized care. A successful partnership between human and machine is not guaranteed. It requires intentional design to ensure the benefits reach everyone. This flowchart shows a human-in-the-loop system. Before the AI executes an action, the decision tree routes to a human override node, ensuring we maintain oversight and safety constraints. We also need global ethical standards covering data privacy and accountability to prevent the misuse of these autonomous systems. Education must also evolve. We must train students to direct and collaborate with AI, rather than preparing them to compete against it. Engineering is already advancing. Our ability to update our policies and our educational models is the true bottleneck to a symbiotic future. By the year 2040, we will likely act as directors, managing vast fleets of machines, rather than their rivals. By handing off the mechanics of survival, humanity gains the time and tools to tackle larger problems, from climate change to the eradication of disease. Prosperity will belong to societies that move beyond a model of competition, embracing the machine as a collaborative extension of human potential.